What's up, everybody? Welcome back to another Tuesday night. It's 9 p.m. on Tuesday. You know what that means. We're going to be continuing with learning the Rust language. We're going to have a fun time with it. If this is your first time joining us, welcome to the chat. Welcome to the stream. We've been going through the Rust book. No worries if you're not caught up. You can easily catch up. We have all the videos from the previous sessions posted on YouTube. So you can find those here on my YouTube channel. Just search Tom McGurl. I'll also post the channel link in the chat. And there you can find chapter 1, 2. That's together in that video there. That's part 1. Chapter 3 in the part 2 video. We got chapter 4 in part 3. And today we'll be finishing up chapter 4. We didn't finish it last time. And you can also find some other videos from some past streams where we set up a live serverless backend using AWS Lambda, DynamoDB, S3, and TypeScript, as well as when we built a React Native app with TypeScript, Recoil.js, React Native using Expo. So check that out. That was pretty cool. That's a much longer series, so if you're looking for something more one-off, you'll probably want to check out that AWS Lambda one. And then if you want to learn Rust, hey, we're going through the book. We're going through the main book that the Rust language recommends. It's the Rust programming language, the book as it's referred to. It's been a lot of fun. And today I'm excited because we're going to be finishing chapter 4, which has been a really awesome chapter. It dove into ownership in the Rust language. Ownership is a big important part of how we handle memory without having garbage collection. So we learned about ownership. We learned about passing references. We learned about pointers to references. We learned about getting ownership, giving it back, or not taking ownership. Borrowing, right? Borrowing was a big thing. So today we're going to finish up with section on slices. Then we're going to go back and do some of the examples that they outlined at the end of chapter 3, the control flow chapter, as you might remember. And yeah, we'll go from there. So again, check out the YouTube if you missed the videos. You can watch it on 1.7 speed. You could breeze through it. Each stream is going to be around 2 hours, but crank up the speed, right? You can't crank up this. It's live. It'd be a little weird, but you can crank up the YouTube video. So check it out. If you like what you see, hit that subscribe button, hit that like button. Really appreciate everything there. And then also check it out on Twitter. I post when I go live here. Also any updates. So, all right, that said, that stuff out of the way, let's do a quick little recap of where we left off. So last time we talked about chapter 4. So ownership. Prior to this, chapter 3, we were talking about concepts that you would see in other programming languages, right? So concepts like strings, characters, but here, and control flow even, right? Like if statements, loops. Here's where we actually got into a core feature of Rust, which is ownership. The notion of borrowing, lending things, getting back values, taking ownership of values, references, dereferencing something, getting its actual value, having a pointer to its value. So that's what we started out with. And so we covered ownership, we covered references and borrowing, and we followed along by writing some examples. So we had some examples here of ownership and functions, and I'll go into this in a second. Maybe we'll go through this first main function, just kind of outline what it's doing. And then today we're going to be doing part 4.3 because it took us a little while to get through those first 2 parts. There was a lot of material there, and we wanted to spend a good amount of time on it to make sure we understood it thoroughly. Here we're going to do chapter 4.3, the slice type, where we'll be learning about slices, slices of arrays, slices of strings, and so forth. So should be pretty cool. But let's quickly recap ownership and functions. So this was just basically, I don't want to go into too much detail because you can watch that video on YouTube, but it's basically about how when you pass variables around, right, you pass data around, functions can take ownership, or you can give somebody a reference. And this is going to give you some sort of protection, right? So we want to make sure that 2 things aren't referring to the same piece of data and manipulating the same piece of data, creating a race condition, right? Or an access error. So here we had our function. We wrote some basic functions like take ownership. So we have the string, and we're using the string from, which you may remember is different than using just a string literal. The string from is going to create a string reference, right? So it's going to actually create a string that can expand. So not like a set string of a certain length. This is a string that we can modify, we can add to. And so we have string from hello, and it's of the capital S string type. And we pass it to this function called take ownership, which accepts type string, and prints it. And now this function actually takes ownership of that string there. So you can see here, S comes into scope. We have the comments, S value moves into the function and is no longer valid here because take ownership takes the value or the ownership of that. And in this case, it doesn't return it back. It just prints. And so the ownership is gone. Then we had an example of making a copy. So we pass it X to this function and makes a copy, takes it, prints it out. So X, the reason it makes a copy is because it was what we call, it inherited from the copy trait. Basically, the way you can think of this is the difference between pass by value or pass by reference. This is like a primitive data type. So you can think of a character, an integer, an unsigned integer, as a value that accepts the copy trait. Booleans also accept the copy trait or have the copy trait, we could say. And so you don't give, when you send this to a function, it doesn't take ownership. It's when we're dealing with those more complex types, such as string, array, that's when we start passing by reference. Whereas here, you can see makes a copy, we can print it, and it'll be fine. We can still use X here. And I'll run this in a second so we can see the output. But what you can also see here is we have gives ownership. So here we create S1, we call gives ownership. Gives ownership returns a string of that string type. And so it creates that string here, and then it returns it. So now the ownership is in this function. So S1 would actually be equal to the string hello. Then we did string from hello, where we created a new string, and we passed it to this function, takes and gives back. And so what this is going to do, I'm just going to throw myself over here. What this is going to do is it's going to take a string and return a string. And all it does is it just returns the string back. So it gives back the ownership. And so S3 now contains that string. Then we did some other stuff where calculate length and take ownership. So this is, we're passing it S3 and we're getting back S4 and a length. So you can see calculate length and takes ownership. It calculates the length of the string that was passed in, and it returns that string and the length back. Calculate length with reference. So this was the difference. This is when we don't actually give ownership, we just give a reference. So we're passing S4 to calculate length with reference. Calculate length with reference specifies that it takes a reference to a string, calculates the length, and again, we can still use that here. So if I run cargo run here, I'm going to go into my projects. I'm going to go into ownership. I'm going to run cargo run. Oh, actually, what I'm going to do is I'm going to compile ownership and functions. Which is inside source. So I have to do rest c /ownership and functions. We get a little warning, and that's okay. It's just telling us that we didn't use that. Or if it's unused, so we should prefix it with an underscore. And then what we'll run is we'll just do /ownership and functions. Oh. And there we go. We see that hello is there, 5, X is now 5. Hello chat, the length of hello chat is 11. So it printed out all that stuff. And you can see we still have references there. So again, this is just a quick recap. Go back if you missed it and watch. I highly recommend part 3. It was super fun figuring out about borrowing, references, and super important. So check that out. It's going to be important. All right, so now we're going to get into the slice type, which is what you are here for if you already saw the previous one. And if not, it's still relevant. It doesn't go too far into what we just learned, but it's very important. So the slice type, let's take a look. The slice type is another data type that does not have ownership. Another data type that does not have ownership is the slice. So slices let you reference a contiguous sequence of elements in a collection rather than the whole collection. So rather than the whole thing, a piece of it. Here's a small programming problem. Write a function that takes a string and returns the first word it finds in the string. If the function doesn't find a space in the string, you could assume that the whole string is one entire word. So you imagine a sentence, you'd return the first word because you'd look for the space, return that first chunk. If there is no spaces, you can assume it's one single word. So let's go ahead and let's create a space where we can actually mess around with this. So what I'm going to do is, let's go up here, get out of the way here, and I'm going to clear this. And I'm going to create a new project. I'm going to call it slice type. I'm going to go into, I'm going to remove slice type and name it with an underscore. So cargo new slice type, for no reason, but just to match hello world and hello cargo. All right, so slice type we have here, and I'm going to go ahead and open that here. There's ownership, guessing game, functions here, slice type, and again, we're going to get the main and our cargo toml. So let's look at this function. So first word, let's try to find it. So fn, which means function, first word. It's going to take a string reference, so that's what that means. That's a string reference, and it's returning a question mark. Okay, that's just because we don't know yet. Let's dive in more. The function first word has a reference of a string as a parameter. We don't want ownership. That's why we use the reference. So this is good. But what should we return? We don't really have a way to talk about part of a string. However, we could return the index of the end of the word. Let's try that. So basically, we don't have a way it's saying to return like a substring like you would see in JavaScript or maybe Python where we just take a chunk. So it's saying let's just return the index of where the first word ends. So if we have a sentence that looks something like this, let's see, let's imagine here, I'm just going to comment it down here. Let's say we had a sentence that looked like this. The first word would just be because we'd find the space, and that would be at index 0, 1. That would be at index 1. So that's what it's saying. Let's return that. All right, so let's try that. So what I'm going to do here is let's take a look. So it's saying that we're going to return uSize. uSize means the index. uSize is the type used for a size of an array or a size of a string or the index. So we're going to use uSize. And then what we're going to return here, it looks like we're going to grab the bytes from this string. And so let's see, let bytes equal s.asBytes. We can see here if I hover over this function, if you don't know what it means, we can click it, and it gives us, this is the awesome thing about the Rust plugin, right? It gives us the documentation right here. So it returns a byte slice of the string's contents. The inverse of this method is from UTF-8. So if you had the bytes, you can use the inverse from UTF-8. So string hello, assert equal, so it's saying, assert these are the bytes. So 104 represents H, 101 E, 108, 108, 111, and that's the bytes. So it's going to go to those individual bytes. And don't worry, we're not going to have to compare the number. We're not going to have to know the number. There is a way, which you'll see in a second, to actually compare it to the byte literal. So let's do asByte. Bytes. It's a function, and we're going to end it in a semicolon. And now it looks like we're creating an iterator. So I'm just going to copy this, and then I think we're going to go into what it's actually doing in a second. Where's my, there we go. In bytes.iter. If you look, it actually will say what iter does too, I believe. So if we do .iter, returns an iterator over the slice. So we'll do iter. Enumerate, which we'll see what that does in a second. And then here we're doing, I think, what is the byte literal check. So if item equals byte literal, space is what we're looking for. Then we're going to return I, which is the index. And then we're going to, down here, s.len. And so that is just the length of s. So here we return I. So if we found a space, if we don't find a space, it goes to line 14. There's no semicolon here, so it is an expression, and so it will return this. So the whole word. So if there's no space, it will return the whole word, so it returns the whole length. So now we have our first word function. So let's look at what it does. Because we need to go to the string element by element and check whether value is a space, we convert our string to an array of bytes using the asBytes method. Next, we create an iterator over the array of bytes using the iter method. So that's this function we called here. We'll discuss iterators in more detail in chapter 13. For now, know that iter is a method that returns each element in a collection, and that enumerate wraps the result of iter and returns each element as part of a tuple instead. So it returns it as a tuple. And that's how we're getting this nice syntax here where we're pulling out two things. We're pulling out the index and the item. And so enumerate is going to do that for us. And if I hover over enumerate, let's see if it actually will explain what that function is. It'd be nice to see the docs. So we're not getting it, I think, because iter may not know the type, but so enumerate is going to return a tuple instead. The first element of tuple returned from enumerate is the index. So this is really cool. This gives us the index. And the second is a reference to that element. So it's a reference. This is a bit more convenient than calculating the index ourselves, because generally we'd have to use like for, in JavaScript we'd be doing for I equals 0, I plus plus, we keep track of that index. This is, we're just iterating over it. When we find the space, we say, hey, what index was that at? We don't need to know that or keep that in memory or anything like that. So a little bit easier to keep in your head there. Because the enumerate method returns a tuple, we can use patterns to destructure that tuple. And so we saw pattern destructuring. It's basically this thing returns a tuple, and we are pulling out those here. The first one being index, the second one being a reference to the item itself. Pretty cool. So in the for loop, we specify that a pattern has I for the index and item for the single byte in the tuple, right? Because we get a reference to the element from iter enumerate, we use the ampersand. Awesome. Inside the for loop, we search for the byte that represents the space by using the byte literal syntax. This is what we were talking about, the B. Otherwise, we'd have the number, right? If we find a space, we return the position. Otherwise, we return the length of the string by using s.len. That's what that's doing. So pretty cool. Let's try it before we go any further. Let's try, let's go ahead and do s equal string from what's up Twitch. And then we'll go ahead and pass it to first word. So we'll say let first word, let's say let word equal first word, and we're going to pass it a reference to s. So we're going to do s, and we're going to, and that semicolon, and then we're going to just print it. Print ln the first word in is, and so we're going to do s comma word. And again, we can use s here, right? Because we passed a reference. Right? If we gave ownership, we wouldn't be able to use s. But we passed a reference, so we're still going to be able to use it. So the way we'll run this is we will just run cargo run. It's going to build and compile. And it printed out hello world, which isn't what we wanted because I forgot to save. So now I'm going to save, and we're going to do it again. So it's compiling. It compiled. And it says the first word in what's up Twitch is 6. Ugh. Because we just returned the index. Not cool. We didn't actually return the first word, but hey, our code works, but it just gives us the index. So now how do we grab, right? We just want the first 6 characters. So that's what we're going to figure out next, how to grab a slice. And also we're going to find out why having just that index unassociated to the string is not ideal. Okay. So we now have a way to find out the index of the end of the first word in the string. And we did that correctly. But there's a problem. We're returning a usize on its own, but it has no meaningful number, but it's only a meaningful number in the context of the string, right? It only means something because it's the index of something with the string. In other words, because it's a separate value from string, there's no guarantee that it'll be valid in the future. Consider the program in 4.8 that uses first word function. So what we're saying here is we have an index, but it's meaningless, right? On its own. It only means something in reference to that string because it's an index of that string. And in any other language, you would be thinking, well, that's fine, right? Like JavaScript, we may keep an index separate, than the thing itself. But it does create problems in this, right? So what if in the example 4.8, we call clear on the string and it no longer exists? Then we have this index floating around that actually refers to nothing because that string no longer exists. So you can see that here. We have a string called hello world. We get the first word index, and then we clear it. Word still has the value 5 here, but there's no more string that we can meaningfully use the value 5 with. Word is now totally invalid, right? So pretty interesting. And it's a usize, right? So it actually does refer to a size or an index. It's not like it's just an integer. It's a size. It's a U size. So that's the type. The program compiles without any errors and would also do so if we use word after calling sclear, because word isn't connected to the state of s at all. Word still contains the value 5. We could use the value 5 with the variable s to try to extract the word out, but this would be a bug because the contents of s have changed since we saved 5 in word. It's gone, right? It's cleared out. Having to worry about the index of word getting out of sync with the data in s is tedious and error prone. It makes sense. It makes sense. I not something I would normally think about, right? In like a language, JavaScript, Python, it's not something I would think about, but it makes sense. And this sometimes happens. So you get an index out of bounds. Its signature would have to look like this. So we can see here, what if we had a function called second word? So managing these indices is even more brittle if we write a second word function. So we have this function second word that takes a reference to a string and returns the first word and the second word. Now we're tracking a starting and ending index. And we have, so the second word meaning where it starts and where it ends, because it doesn't start at 0. So we can even write this just so we have it. So I'm going to write this here. So we'll do fn second word. Again, it takes a reference to a string. And it's going to return a tuple with the starting index and the second index. Again, they're going to be used sizes because they refer to an index. And so what we'll do here is it would be the same thing as this, but you'd try to find the second one. So the first one will look for the first space. It finds it. It returns it. We want to look for the first space, store that in this first one, find the second space, store that in the second one. So let's try to write it. It doesn't actually have us writing it here, but fun exercise. Let's do it. So let's pull in bytes. Let's copy this. This is going to be the same. We're going to get the bytes. Let's just copy this as is. We can even call first word, get the index, and then start from there. Yo, that'd be pretty cool. But let's just write it like this just to play safe. So we're going to grab our bytes. If we find a space, how would we do this? So we'd have a mutable first index equals, maybe we'll start at 0. And here, instead of returning I, we'd want to actually set first index. Right? But we need to mark that the first one's found. So it's how we do this in any other language, right? So we'd walk through, we'd say, okay, have we found the first index? Yes, we'd mark that in some sensible way. If we found the first index, we would continue through the loop. So let's see what this looks like. So we have a string. We'd scan through, find the first space, say, okay, we've passed the first word. We now have the index of the second word, and then we find the next space. So we could say first index. We could even store found first equals false. Start out with false. So if item B, and I believe this is, I don't know the syntax for this yet, but we'll try it, and found first, I'm just messing around. I don't even know if this is syntax yet. Else if item equals B and not and found first, then we'll return first index and I plus 1, right? Because we don't want the space itself. Otherwise, we'll return 0 s.len. Well, so if there's no second word, we would actually return, in this case, what would we return? We'd probably return, let's do, just for now, we'll do s.len, s.len. Okay, so what is this saying? So this is saying here, probably the first index, expected, so mismatched types, expected found tuple, expected unit type, found tuple. So one thing that we probably want here is first index. So first of all, first index needs to be a usize. That's first step. This one's a bool. It's inferred. Here we're basically saying first index equals I plus 1 because we found the space. And then here, if we find another space and we've already found first, then we need to return, let's see, expected found tuple. Let's see what that's about. Let's see if I just change it to 0 and 1. So it still doesn't like that. So let's see if I just return it. So now it likes it. And so here we also have to set found first equals true. All right, so let's see if this works. So we're going to go up here and let's say let second, let's say word 2 equal second word. We're going to pass it, again, a reference to s. And then we'll print out the second word starts at, oh, again, and don't forget this returns a tuple. So we'd actually want start end. The second word starts at start, well, actually, sorry. Starts at blank and ends at blank. And then we're gonna do start end. Let's try it out. The second word starts at 7 and ends at 10. So yes, that's correct. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We did that incorrectly. In this case, it's going to be I minus 1 because we have to go before the space that we found, right? So let's try that again. 7 and ends at 8. Perfect. All right, so we did it. Cool little example exercise. Anyway, it's kind of a tangent. They didn't actually ask us to do that, but it was fun. So now we're tracking and starting and ending index. So we have the starting and ending index, and we have even more values that we calculated from data in a particular state but aren't tied to the state. So again, we have the problem where we have these indexes, but they're not tied to the string that they are the indexes of. We now have 3 unrelated variables floating around that need to be kept in sync. Luckily, Rust is a solution for this. Who would have thought? Who thought they'd bring this up and not have a solution? We all knew it was coming. String slices. A string slice is a reference to a part of a string, and it looks like this. String from hello world. Pretty cool. Here we have hello 0 to 5. So this is inclusive. So index 0 to index 4 inclusive. It excludes index 5. Again, here we have 6 inclusive all the way to index 11. So that's going to include characters 6, 7, 8, 9, and 10, those indexes. So similar to taking a reference to the whole string, but with an extra. 0, almost like the range information. Rather than a reference to the entire string, it's a reference to a portion of the string. So just like a chunk. We can create slices using a range within brackets by specifying the starting index and the ending index, where the starting index is the first position in the slice and the ending index is one more than the last position in the slice, so exclusive. We would say that's inclusive. starting, exclusive, ending. Similar to something you'd see in like substring or slice. Internally, the slice data structure stores the starting position and the length of the slice. This is what the actual pointer is storing internally. Okay, so the slice data structure stores the starting position and length of the slice, which corresponds to the ending index minus the starting index. So that's how they get the length. Makes sense, right? So if your starting index is 0 and your ending index is 5, your length is 4. 0, 1, 2, 3, 4. Your length is 5, sorry. Because it corresponds to the ending index minus the starting index, right? So 5, your length is, again, index 0, exclusive on the end. So if you have 0 to 5 range, your length is 5, which makes sense. So in the case of let world 6 to 11, world would be a slice that contains a pointer to the 7th byte counting from 1 of S with the value of 5. 5 coming from 11 minus 6. So letting us take chunks. Pretty cool. Here's a diagram of that. S is, again, a pointer to the entire string here. And so that's why we have the pointer. We have the length of 11 and the capacity of 11. World is the slice, and it just points to 6, has a length of 5. So it doesn't have a pointing to the end. It just knows the length. So what it'll do is it'll point to the first part and has a length of the contiguous amount that it needs to hold. So pretty interesting. With Rust's ... range syntax, if you want to start at the first index 0, you can drop the value in front. So you can do, instead of 0.2, you can do ... 2. Pretty neat, nice shorthand. And you can do the same with the end. So we see that here. You can also drop both values to take a slice of the entire string. So this would essentially copy the string, right? But remember, copying, right? Not really the same. This is going to take a slice of the whole thing. And actually a slice, we'll see, has a different type than string. That's going to be important. String slice range indices must occur at valid UTF-8 character boundaries, right? You can't go beyond the bounds of the string. If you attempt to create a string slice in the middle of a multi-byte character, your program will exit with an error. For the purposes of introducing string slices, we're assuming ASCII only in this section. A more thorough discussion of UTF-8 handling is in the Sorting UTF-8 Encoded Strings, Text and Strings section of Chapter 8, which we'll get to. We'll get there. Oh, we'll see. No, we'll get there. With all this information in mind, let's rewrite first word to return a slice. The type that signifies string slice is written as, remember we saw this? We saw this. We were in the chat. We had folks in here. We're mentioning at string. We were wondering what that was. Now we see it. It's a string slice. So it's the type representing a chunk of a string or a whole string. So it's almost like a more flexible type for the string. So let's rewrite our first word so that we're actually taking advantage of this. So instead of item B here, instead of returning the index, and instead of returning the index here we'll return the whole array, which we know we do ampersand s ... That's will return the whole array. And here we'll return a chunk. So we'll say s, and we'll start from index, or we'll start from 0, right? We're going to start from the beginning, and we'll go until the index exclusive. So we're not going to include the space. And we are going to return that. And here we're going to leave off the return because we have an expression here. Now, we're no longer returning a useSize. We are actually returning a chunk of a string. So our return type is no longer useSize. It's going to be that new type we just learned about, string. And so what I'm going to do here is I'm going to run cargo run. And we'll see the first word in what's up Twitch is what's. Awesome. Now let's go ahead and we can modify second word to do the same. Let's see if they have us do that first though. We get the index of the word in the same way that we did in listing 4.7 by looking for the recurrence of the space. When we find the space, we return a string slice using the start of the string and the index of the space as the starting and ending indices. Now when we call first word, we get back a single value that is tied to the underlying data, right? Because it's a chunk of that underlying data. It's actually referencing the same thing. So when that thing's cleared and removed from memory, so is the string chunk. So they're actually tied together. It's going to be a little safer. The value is made up of a reference to the starting point of the slice and the number of elements in the slice. Returning a slice would also work for the second word function. So they don't give us the function. Let's code it up here. So for the second word function, what we're going to do, we can keep the same logic, But we're just going to go ahead and return. We're going to change our return type to be, right, a string slice. And then here, we're going to do the same thing. We're going to return, instead of the whole string, we're actually just going to return this. If there's no second word, we're just going to return that. And then here, what we're going to do is we're going to return s ampersand first index dot 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 to index, because again, it's exclusive. We don't need that -1 anymore. And I messed up here. It should be ampersand s. All right, let's try it out. So here we have an error because we're still trying to destructure a tuple, but we're no longer given a tuple. So we're going to change this to word 2, and we're going to change this to the second word is, and now let's go ahead and clear this, and I'm going to put myself over here so you can see what's going on. I'm going to run cargo run, and here we'll see the first word in what's up Twitch is what's, the second word is up. So awesome. So pretty cool. String chunks. I think it's pretty cool. All right, we now have a straightforward API that's much harder to mess up because the compiler will ensure the reference into the string remain valid. Remember the bug in the program in listing 4.8 when we got the index to the end of the first word, but then cleared the string so our index was no longer valid? The code was logically incorrect, but we didn't show any immediate errors. The problem would show up later if we kept trying to use the first word index with an emptied string. Slices make this bug impossible and let us know when we have a problem with our code much sooner. Using the slice version of first word will throw a compile time error. That's what we want. We want to avoid runtime errors. The other one would have caused a runtime error. This is actually going to throw a compile time error because it sees us trying to use potentially a string slice of a string that no longer exists. So if it sees us call clear on the string and then we take a slice, we have a slice of it, try to use it, it's going to be able to call that out. So very powerful stuff. And again, this is why this is a benefit that we get from a compiler. And if we're going to use a compiled language, we want the compiler to catch stuff like this, right? And that's why I always say, it's okay to get errors from the compiler. You should lean on them, and you really should. If we weren't leaning on them, we were writing perfect code every time, it wouldn't matter. The fact is, we don't, and we should lean into that compiler, let it tell us what's going on. We have fantastic error messages in Rust, and we'll get these benefits. And then we know we're not going to run into these things at runtime, which would affect our users. They're unpredictable, right? Catching them ahead of time. Very powerful stuff. Okay, so here we have string hello world, word, first word, s that clear, print first word is word, and it's going to print an error. So let's try that. Let's try that out here. So we're going to do, I'm going to clear s, and it should actually throw an error because we're trying to use it twice. So let's do s.clear. Okay, so right away it's saying here, cannot borrow s as mutable as it is not declared as mutable. So let's declare it as mutable. Very cool. Nothing here, nothing showing up in red here. Let's try to run cargo. Let's just run cargo check to run the compiler. Let's run cargo run. So the first word in blank is blank, so it didn't do anything. And I didn't get an error like they said I would. What's going on? Mute S. We cleared it beforehand, which is fine, right? We were just dealing with a cleared string. Let's try to clear after the fact. So we have first word, let's clear it. And let's also move this here. So we're trying to use it here after we get the words, we then clear it, and then we're trying to use it. Let's see. It'll tell you right, let's see, it's gonna say right here. Cannot borrow S as mutable because it is also borrowed as immutable. So from these likely. these are taking, let's try if we make these mutable. Let's see if it stops complaining. It's the same compile error that they're saying here. So it's saying cannot borrow s as mutable because it is also borrowed as immutable. So here it's borrowing it as immutable, meaning it's trying to create an immutable reference to it. And here I'm trying to mutate it. So pretty cool. We don't even have to run it to see that error. So that's pretty nice. Awesome stuff. And I don't need it to be mutated. Let's see if it tells us that. Variable does not need to be mutable. That's awesome, right? It's telling me right there it doesn't need to be mutable. So we'll get rid of that. Pretty cool. All right. Recall from the borrowing rules that if we have an immutable reference to something, we cannot also take a mutable reference. We learned that in the last chapter, or the last section of this chapter. Because clear needs to truncate the string, it needs to get a mutable reference, right? It's going to alter it. It's going to truncate it to be empty, so it needs a mutable reference. Rust disallows this, and compilation fails. Not only has Rust made our API easier to use, but it's also eliminated an entire class of errors at compile time. So pretty cool. Spooky. Nice. String literals are slices. Wow. Who knew? This comes back to what we saw, right? We were talking about the string slice type. Recall that we talked about string literals before, literals being stored inside the binary. Now that we know about slices, we can properly understand string literals. All right, so we have a string literal hello world here. The type of S here is string slice. It's a slice pointing to that specific point of the binary. This is also why string literals are immutable. And string slice is an immutable reference. So that's why, right? We also know that these are declared on the stack, not the heap. So pretty cool. String slices are parameters. Knowing that you can take slices of literals and string values leads us to one more improvement on our first word, and that's its signature. So you'll recall our first word and second word both take a string of type, capital S, like an actual string type, and return a string slice. But here we can actually modify it so the input type is also a string slice. A more experienced restation would write the signature shown in 4.9 instead, because it allows us to use the same function on both string values and string slice values. So that's pretty cool. So let's change it. Improving the first word function by using string slice for the type. That's awesome. If we have a string slice, we can pass that directly. If we have a full string, capital S, we can pass a slice of the entire string. So it makes this much more flexible and more general use without actually losing any of the functionality. So super cool there. So here's our file name. So we have my string, word, first word, my string, and they're making a copy of it. So let's try this. Let's see if the way we're calling it now works by just changing the signature. So I'm going to clear this out. I will put myself over here in the top left, so I'm out of the way. I'll run cargo run. So it's still working here. We could also, instead of doing passing the reference to the string here, we can actually pass it as a slice. So we could say s ... Same thing here. Let's call that cargo run. Beautiful, still working. Pretty awesome. And it also works, we can see it works on slices of string literals. So let's create a string literal. And we'll make this one equal hello chat. And we'll pass my string literal here. And let's see if that works. Unexpected token. That's because I forgot a semicolon. Classic. Run that. The first word in the first one is what? And the second word is blank. Ugh. That's because, let's see. Hello chat. It should be chat. My string literal. We're passing my string literal. ... Word 2. Let's see what we have wrong here. Let's just try passing it like this first and see if it works. as a reference, remember? So that didn't work. But if we do the range, I know why it's not finding it, because there's no space at the end. We were waiting for a space at the end. So we can actually alter our function to work appropriately. So there's no space at the end, so it never hits this here. However, here we can make an optimization. So we can return this if found first. We could return our first index. So first index. We could also probably just, if we have first index, we can just say, we can start it out at 0. We can do a comparison if it's not 0, but we had this extra found first, which we actually don't need, but let's just do first index dot dot and then s dot len. Else we'll return that. So let's try our function now. And there we go. Second word is chat. So we modified our function so that it works. Pretty cool. And I wonder if there's a nice ternary way to do this. I'm sure there is. In Python we could do this if found first, else this. In JavaScript we could use the question mark. So I'm sure we'll get into that a little bit. Let's Google it. Rust ternary if. Let's see. So you can do a single line, but it just looks like this. So it's just the same thing we have, but on a single line. They have a duplicate issue here. Let's find out what this is. This is going down a rabbit hole. Let's see. Let's go back here, see if there's any. So apparently it needs it. So apparently we don't have it yet. Oh, this is 2015 though. I think this is the issue that it linked to as a duplicate. So I guess we don't have it, but yeah, what they're saying is we could just have, you could write this as a single line, but it works, so move on. Other slices. String slices, as you might imagine, are specific to strings, but there's more general slice type too. Consider the array. We have an array from 1 to 5. Just as we might want to refer to part of a string, we might want to refer to part of an array, and we can do that. Check it out. We can just grab from index to index of an array. That's pretty awesome. The slice has the type, this slice in particular has the type signed integer 32. So instead of @str, it's using @ I32. It works the same way as a string slices do by storing a reference to the first element and a length. You can use this kind of slice for all sorts of other collections. We'll discuss these collections in detail when we talk about vectors in chapter 8. Oh, looking forward to that. All right, we finished the slice chapter. Let's look at the summary. The concepts of ownership, borrowing, and slices ensure memory safety in Rust programs at compile time. The Rust language gives you control over your memory usage in the same way as other systems programming languages, but having the owner of data automatically clean up that data when the owner goes out of scope means you don't have to write and debug extra code to get this control. Ownership affects how lots of other parts of Rust work, so we'll talk about these concepts further throughout the rest of the book. Let's move on to chapter 5 and look at grouping pieces of data together in a struct. Awesome. So pat yourselves on the back. We did it. Chapter 4 is in the bag. Before jumping on to chapter 5, we're going to go back. And there were some exercises at the bottom of chapter 3, the control flow chapter, that I think we might as well jump into. Let's do it. Let's have some fun with it. So, and then we'll continue to chapter 5. We have time at the end of the night. If not, we'll just end there. But we have this information now at our fingertips. So let's go back to our 3.5, and I'll just go over these exercises really quick, and we'll try to run through them. So here at the end of chapter 3, they said we can try the concepts of control flow and expressions to try out these functions. So there's the first one: convert temperatures between Fahrenheit and Celsius. Doable. Generate the nth Fibonacci number. Classic, right? Who's done this before? I've done it. I've been asked in interviews. Classic one. Is it good? It's an interesting one. And this one, which sounds not as fun, but maybe we'll try it, is print the lyrics to the Christmas Carol, 12 Days of Christmas, taking advantage of the repetition of the song. Maybe we'll do something else. I don't want to type all those lyrics. But let's definitely start with the first two. So we're going to do this first one, Fahrenheit to Celsius, and we'll do both, right? Fahrenheit to Celsius, Celsius to Fahrenheit, and back and therefore. So what I'm going to do here is we're going to start with Fahrenheit to Celsius. So I'm going to go ahead and open this full screen. We're out of the book for a minute. We're going to try to, and we can reference that book if we need help. Raise his hands. Warp Fox Omega, welcome to the chat, Warp Fox. It is great to have you here. Awesome. Hope you're enjoying learning Rust. All right. Warp Fox is a good buddy. Good buddy, Tyler. I didn't give away his real name, did I? No. He's a good friend. Thanks for stopping by. Appreciate it. All right. So what we're going to do here is we're going to create a new project for our Fahrenheit to Celsius. So let's go back up a step, and we have our projects directory. I'm going to run cargo new, and we'll just call it temp converter. It's going to create that new project for us. We're going to open up temp converter, go into our source, and let's write two functions. So let's write Fahrenheit to Celsius. Hope I spelled that right. And we'll have the opposite here. I definitely spelled it wrong because I believe there's an H in there, but let's Google it. So we're going to Google the formulas anyway. Fahrenheit. I knew I forgot an H. And I spelled Celsius with a C like an idiot. I am not a speller. You will find that out about me. All right, so Celsius to Fahrenheit, Fahrenheit to Celsius. So to go from Fahrenheit to Celsius, the formula is right here. So this is the formula for, and so what we're going to do here is we're going to accept F as a input, right? We're going to leave off the type for now. I have some thoughts about what the type will be, but we'll leave it off for now. And we'll want to keep this arithmetic like that. This is going to be, that. And this is also just got to be a regular minus. And what is this saying here? Let's see. So it wants us to have a type here. Oh, so we're going to actually return. I think we're going to need a float here because we're doing some math with division. So we're going to say this takes an F64, and we can always change it. It also needs to be unsigned, right? Because we want to be able to, it needs to be signed, I'm sorry, because we want to be able to do negatives. So we'll see. What is this complaining about? Cannot subtract integers. So we'll just convert these to floats. Beautiful. Okay, now we need the opposite formula. We can do the math ourselves, or we can Google it. Celsius to Fahrenheit. So we're going to do C times 9 divided by 5. Oop. All right. Yes. And we have to accept C. It's going to be an F64. We can try integers, but I'm pretty sure because we're doing division, we'll try it. Let's see what works. And what is it saying here? We have to do 9 dot. Because of that, we'll do 9.0. Pretty cool. And we're going to do 5.0 and 32.0. And it's saying we have an extra parentheses. We can ditch those altogether. Oh, maybe not. We can ditch that like that. That should be fine. We need this. All right, so let's see. So we have C times 9 divided by 5 plus 32. And what is this saying? Okay, so what we can do is we can wrap the whole thing in parentheses. Let's clear this up. Let's make this a lot neater. Hold on. We need to say that this returns F64. And so we want to do this multiplication. There we go. So that should handle it. So now we have Fahrenheit to Celsius and a Celsius to Fahrenheit. Pretty cool. Okay, now let me make this bigger so you can all see it. I'm sorry about that. All right, so now we want to, how do we want to do this? What's our interface? Do we want to make it standard in where they type and we convert? Probably. Let's start with reading some basic input, and we can actually pull from some of our previous work. So if you remember, we have our guessing game where we're using standard in. Let's use that. So let's go up here. Let's import that. And then what we're going to do is basically the same thing we did here. We're going to ask them. We'll start by asking them for a input, and then we'll parse it. So I'm going to copy this code, and we'll modify it a bit. So I'm going to just put input a temperature in Fahrenheit. So we'll start with this one. And so what we'll do is we'll say that Fahrenheit equals string new. We're going to read it in as Fahrenheit. And then we're going to convert Fahrenheit to an F64. So we're going to parse it as an F64, not a U32. And so to recap, and here we're not in a loop, so what we're going to do instead of this is we're going to panic. Okay, so to recap, because this goes back to the guessing game as to what we're doing, and you all want to see what we're doing in the new version, what we're doing is we're creating a mutable Fahrenheit string. It's empty. That's why we're not putting anything in here. We're then using standard in, which is what we're going to type, and we're reading the line in from standard in and storing it in Fahrenheit. If it fails, we're going to print this out, right? We're going to throw this exception. Then we take Fahrenheit, we trim it, which removes that new line that naturally happens when you hit enter in the standard in. We parse it, and we're saying we want to parse it as an F64, right? So a signed 64-bit integer. And then we're matching on the result of this parse, because the parse could be good and return an OK, which is successful, or it can have an error. So what we're doing is if it's successful, we're going to say, good, give me the number, store that in Fahrenheit. Otherwise, just go ahead and panic, which will exit the program. And this is complaining because we haven't yet used it. So now what we're going to do is we're going to call our program. So we're going to say let Celsius equal, and we're going to call Fahrenheit to Celsius, and we're going to pass it Fahrenheit. And then we'll just do print ln. is equal to C. And we'll pass it Fahrenheit. And we'll pass it Celsius. And we're going to see something in a second. All right, so we have our program. It's going to call Fahrenheit to Celsius, which is going to take our F, subtract 32 from it, multiply it by 5/9. So let's try to run it. So I'm going to just step into temp converter. I'm going to do cargo run. It's compiling. It's telling me that Celsius to Fahrenheit isn't used, which is good. And it's now asking, please input a temperature in Fahrenheit. So I'm going to put 212. And there you see it. 212 Fahrenheit is equal to 100 Celsius. And then the program closes. Let's try that again. Let's say 32. 32 is equal to 0 Celsius. And let's try something more relevant to right now. Let's try 65, which is about what it is now. Let's say 68, which is equal to 20 Celsius. So I think a perfect day, we're looking at like 68 Fahrenheit, 20 Celsius. Pretty cool. Now we haven't yet taken advantage of our Celsius to Fahrenheit. So one thing we could do is we could modify our API so that we can say, hey, if you pass an F with it, so like 212F, it'll know to convert it to Celsius. Or maybe if you pass 212C, it'll know to convert it to Fahrenheit. But one thing I want to test is let's try that our Celsius one works really quick. And so let's just modify this slightly. So what we'll do is we'll comment this out just to see that it works. And it was complaining because we had no main function. And so what we're going to do is please input your temperature in Celsius. Change Fahrenheit here to Celsius using multi-cursor. Pretty cool. And then we're going to go ahead and say C. I mean, we didn't need to change this part. We could just adjust what we're printing, but why not? And this is going to be Fahrenheit, and this is going to be Celsius to Fahrenheit. And let's try that one. It's going to complain that we're not using the other function, but it's asked me for a temperature in Celsius, so I'll say 0. And 0 Celsius is equal to 32 Fahrenheit. So awesome. So we have a function that can do the conversion. So let's jump over to the other thing, which is the Fibonacci. And if we have time, we'll come back and maybe modify this to actually support checking whether we put a Fahrenheit input or a Celsius input. So we will come back to this. Okay, so now let's try this example here. Generate the nth Fibonacci number. Okay, so do a little recursion. Do looping too, because we learned about looping, but we'll try some recursion. Let's see. Okay, so what I'm going to do is I'm going to go ahead and clear this out, back out a bit, and I'm going to do cargo new nth Fibonacci. Great. Jump in there. And let's just go ahead and close out temp converter, slice type, guessing game, and we'll jump into nth Fibonacci. And let's start out with the same thing. Let's start out with that same input where we ask for the nth number. So the way we'll do that is we'll just import standard in again. Okay, and we will say, please input, let's say, what Fibonacci number would you like? Cool. And again, if you have any questions about what we're doing in the chat, feel free to ask. Just chat away. I'm taking a look. I'll answer as soon as I see it. So we're going to ask what Fibonacci number would you like, and we'll say n. We'll call this n. And instead of an S64, it's going to be a unsigned 32-bit integer, positive numbers, right? We're not going to go negative on this. So n equals trim, and again, if it works, we'll return number. Otherwise, we'll say please input a valid positive number. Okay, so now we'll have n, and remember, it looks like we're redefining n, but again, remember this is shadowing. We're using the same variable name, but we're changing its type, and that's why shadowing is useful. So let's create that Fibonacci function. So we'll call it nth Fibonacci. It'll take n, and we know we're going to return an unsigned 32-bit integer, and n should also be an unsigned 32-bit integer because it's always going to be positive. And now what we'll do is let's talk about this. Let's talk about what the Fibonacci sequence is. So the Fibonacci sequence is a sequence where a number is equal to the two preceding numbers added together. So the sum of the two preceding numbers. So I'm just going to type out here what that means. So imagine you have 0. There's no preceding number, so it's 0. 1 is equal to 0 and no preceding number. So it just starts like this. I don't know why exactly. But so then we have 1, which is equal to 1 plus 0. Then if we do 1 plus 1, we get 2. Then if we do the two preceding, 2 plus 1, we get 3. We do 3 plus 2, we get 5. 5 plus 3, we get 8. 8 plus 5, we get 13, and so on. So it's adding the two preceding numbers. So what that would look like is if we were to just think about it, the formula is n is equal to n minus 1 plus n minus 2. So n is equal to n minus 1, the one before it, plus n minus 2. So that's the general formula. So what we could do is we could figure out recursively the Fibonacci number for n by figuring out the Fibonacci number for n minus 1 and n minus 2. So what we're really dealing with here is n minus 1 plus n minus 2. This is the Fibonacci sequence, right? And here I have an expression, so it'll return this. But we don't want just n minus 1. We want the nth Fibonacci number at n minus 1, right? So this is where it gets complicated. We want the nth Fibonacci number at n minus 1. So here we're saying the nth Fibonacci number is equal to the nth Fibonacci number at n minus 1 plus the nth Fibonacci number at n minus 2. So what do we mean by that? Let's look at the case of 5, 8, and 13. 13, and here, let's draw out this whole thing. So 0, 1, 1, 2, 3. Okay, so 13 is the 1, 2, 3, 4, 5, 6, 7th Fibonacci number. It is equal to the 6th Fibonacci number plus the 5th Fibonacci number. Are those extra parentheses needed? Gonzalo. Good question. So are you referring to here? No, I believe they're not. We could probably get rid of this as well as this. And actually the cool thing is if we compiled it, it would actually tell us when we have unneeded parentheses, which I really like. And again, we're leaving off the semicolon here, so it's an expression. So how do we now compute this? So let's just go ahead and return this, and let's see what happens. We're going to see it's an error, but I'm just going to go ahead and return it just so we can see what the error is. So what I'm going to do is I'm going to say let Fibonacci number equal nth Fibonacci, and we're going to pass it n, and then we'll print ln the Fibonacci number is n, and we're going to pass Fibonacci number. All right, so let's see this. This is probably going to blow up, right? Because you'll see. cargo run. Let's ask for the 7th, so we can get that 13. So this is cool. So it's going to give us a little hint as to what happened. The main thread panicked at attempt to subtract with overflow. Attempt to subtract with overflow. So there was subtraction happening here, and it overflowed. Why did it overflow? Because it kept going back, right? So let's write out this again so we can see what happened here. So we had 1, 1, 2, 3, 5, 8, 13. So it kept going back so far that it actually it went into the negatives, which means that we end up in a signed integer space. We're only tracking unsigned integers. So it properly caught that error. And that's because we need an edge case, right? So that's where our conditional is going to come in. So we can check if n equals 1, right? If we get to the point where it's 1, well, we know we can just return 1. So if n ever equals 1, and here you can see it's going to tell us unnecessary parentheses. So pretty cool. So here we're saying if n equals 1, we'll just return 1. We're done. We could also check if n equals 0, but let's see what happens now. So what's going to happen? Let's walk through it in our head. So we have n minus 1 plus the nth Fibonacci number of n minus 2. So when I give it 7, I want to come to 13. So what it's going to do is it's going to find the nth Fibonacci number for 6 minus 1, which would be 5. Or sorry, 7 minus 1, which would be 6, and 7 minus 2, which would be 5. It's going to recursively try to find those numbers. So let's try this one out and see if this works. So now we're doing a check for 1, and we return 1. So let's try it out. Clear that, cargo run. Let's ask for the 7th. Oh, so we still panicked, and that's because if n equals 1, we also need to check for else if n equals 0, return 0. Cargo run, ask for 7. 7th Fibonacci number is 13. So what happened here? Let's step through it. So we asked for the 7th number. So when we first call this function, it requests the nth Fibonacci for 6 and 5. The 6th one requests the Fibonacci for 5 and 4, and the 5th one requests the Fibonacci for 4 and 3. And so it's recursively calling this function, and eventually we return 1. And you may say, well, wouldn't that just end up, we only called it twice, wouldn't we end up with just 2? But no, what's happening is, since we're consistently returning 1 plus the nth Fibonacci, it actually ends up adding up. So this is what the algorithm for Fibonacci looks like in Rust. So we can see when n equals 1, return 1. If it ever equals 0, just return 0. And so if we run it, we see the 7th Fibonacci number is 13. Let's ask it again. Let's ask it for the 6th, which we should find out is 8. Awesome. And let's ask it for, I don't know, the 10th. 55. All right, let's go crazy. Let's ask it for the 55. It's going to be nuts. It might run out of space. It might blow up. Let's try it. And that's how you crash your computer, people. So why, you may ask, did that take so long? Well, it's because it's recursing these functions, right? So it's adding these function invocations to the stack, and we can eventually blow it. So what I'm going to do is instead I'm going to call, let's try something easier. Let's try like 13. 233. So pretty cool. All right, so that's our Fibonacci sequence function. Pretty cool. We used recursion. We could use a loop. That would be a little bit different, right? We'd want to loop backwards, but I think recursion is great for Fibonacci because it expresses it in the actual meaning of the pattern, which is that a Fibonacci number is equivalent to the sum of the two previous numbers in the sequence. So pretty cool. All right, let's hop back over to our temperature converter and see if we can actually make it so that it understands Fahrenheit and Celsius. I think that would be pretty cool. So we can no longer parse the input. If we're going to put an input like this with F or C. So let's run this. Let's go back up here and let's go to temp converter. Grab some water. Ugh. So I don't get dry here. All right. So if we go into temp converter and we go ahead and run cargo run, if I try to type 0C, we get an error. So thread panicked at please input a number, because we didn't input a number. So we won't be able to use this conversion. So we'll actually be accepting a string. We can trim it, but let's not yet parse it. So let's go here and we'll take in a string. And so here we'll have Celsius as a string. We can see what's it complaining about here. It's saying that, oh, because we have a match. We're going to get rid of the match. So we're taking in a string. We have Celsius, which is a string. We've trimmed it. So let's just go ahead and print ln. And let's change it from Celsius to input. Or let's change it to temperature. And I'm just going to put a string here so we can see you input comment those out, and let's just run cargo run. I'm going to put 30, let's put 0C again, and it says you input, because I spelled it wrong, 0C. All right, so now we're going to use something we learned in our slices. What we're going to do is we're going to parse the bytes until we get to the presence of a C or an F. And once we do, we're going to parse the part that precedes that. Now, we'll still have invalid inputs to handle, right? We'll still have to be dealing with, well, what if someone passes, you know, they don't pass a C or an F, right? Or they pass 1 billion or 1 billion D, and no one knows what that is, 1 billion D. We're going to handle it, right? So let's do what we just learned in our slicing. And I'm glad we did the slicing because now we have the power to do this. And maybe we could do it without, looking at that. But I think it's going to really help us. So over here on the right, I'm going to go ahead and open up our slice type main function. Keep that there because we're going to use this as bytes. And so what we're going to do is we're going to read the bytes and look for the presence of an F or a C. So here's how we're going to do it. We have our temperature. So what we're going to do is we're going to say let temperature bytes equal temperature dot as bytes. So now we have those bytes, and we're going to loop over them. So for index, that's going to be the index, and the actual byte itself in temperature bytes. We're going to use the iterator, and we're going to enumerate. That's how we're going to get that index and the actual item. So again, normally we'd only get the item, but because we're using enumerate, we're going to get that index along with it. And now we're going to do a check. If the item equals, and we're going to use the byte literal, if it equals F, right? Or lowercase f, and maybe we can convert the byte to be lowercase, but what we'll do is we'll just do a check for item equals BF for now. Then what we'll want to do is want to return the string that's everything up to the point where we found this. And so we learned how to do that. Temperature. Oh, one thing worth noting is temperature is immutable. So we'll want it to be mutable if we are gonna, well, in this case, we're gonna take a slice of it, so it's actually okay, but we want to do something with that slice. We're gonna want to store that slice. So maybe we move this to a separate function. It'll be a little bit nicer because we're gonna be doing some logic here. So let's do that. Let's say, we'll say determine temperature from string. And so it's going to take a string. We're going to use a string slice. We're going to take an at string slice, and it's going to return an at string slice. And we're going to move this logic here, because it would be nice to break up these functions a bit. And so the string slice that it's going to accept is, let's call it temp string. And here we'll refer to it as temp string. Temp string. All right. Okay, so determine temperature from string takes a temp string of type string. String slice, and it's going to return a string slice. Temp string bytes is temp string as bytes. And then here it's complaining because we haven't finished. So what we'll want to do here is for I item in temp string bytes, iterate and enumerate if item equals B. So what I can just return this for now and it will stop complaining. There we go. So basically, if we find F or F, we want to return the slice that is everything before this. So the way we can do that is we can say, again, at S, we're going to do temp string, and we're going to grab everything from 0 to index. Because we found that F or C, we don't care about that. In this case, we found that F, we don't care about that. So we're going to return everything up until the index. And so here it's saying we need to actually return it. So what we'll do is we'll say return that. Okay. And then here we do else if item equals, and we'll just copy this and change it to a C. C and C, and we need an extra if here. Well, then we will return, and we'll also want to somehow indicate whether it's Fahrenheit or Celsius, which we'll do in a second. But for now, we can do this. So and if it's neither, meaning maybe if it's left off, we'll just return temp string. We'll return the entire string, which is, we'll use that for that. Okay, so this isn't going to really help. This is just going to trim off the F and the C. What we actually need to know is whether or not it's Fahrenheit or Celsius. And we haven't learned structs yet, but I'm assuming we could use a struct to say, type and then the actual temperature. But so since we didn't get into that yet, what I'll do instead is I will change this function so that we do a check explicitly for Celsius and a check explicitly for Fahrenheit. So the way we can do that is get Fahrenheit temperature from string. I'm going to just copy this code. And again, this isn't the way we would do it. We'd just want to loop through it once and return probably a structure that says, hey, this is the type, it's Celsius, this is the temperature. But because we haven't gotten into that, I'm just going to create two separate functions. And we will just go with that for now. And so I'm just getting rid of those extra cases there. Formatting. And so now we have these two functions, and basically what I want to do is if I don't find it, I want to just return an empty string. Okay, so now what we'll do is we'll have our temperature, and I'll say let Celsius equal and we'll say get Celsius, and we'll pass it temperature. Call the same thing but with Fahrenheit. And then we'll do a check if Celsius. And again, what we would probably want to do here is we could probably do like an or, like temperature equals this or this, and play off the fact that an empty string may evaluate as false. We'd have to see. We could return a tuple. That would be a good way to do it. Let's try this, and then we'll modify it to return a tuple. We can return a tuple with the temperature and the type, and then we can do a check on the tuple. We can do a match. Yo, look at this. Let's do that. But first, let's just try this to see if it works. So if Celsius does not equal string, we will return. So what we'll do here is else if Fahrenheit does not equal. So here we'll print ln. We'll say temperature is equal to F, and we'll pass it temperature, which is the temperature they passed in, and Celsius. And we'll do the same thing here. We'll say it's equal to Fahrenheit, and then otherwise we're going to print we'll panic. Please enter a valid temperature. Did I spell temperature right? I don't even know. Don't even know. All right, so let's do this. What is this saying? This says unnecessary parentheses around if condition. Let's get rid of those. Habit. Old habits. Old JavaScript habits. All right, so let's try this out. So basically what we're going to do here, again, just to recap, we did it kind of like in not the best way, but we'll modify it. We read in the input, and then we check first if it's Celsius. We do that by checking if the presence of a C character, and if so, we return everything up until the C, otherwise an empty string. We do the same thing for Fahrenheit, and then we do a check. Hey, if Celsius wasn't empty, we're assuming it's Celsius, and we'll print the temperature as converted to Fahrenheit. So we actually have to call our function to do the conversion. And then the same thing here for Fahrenheit. If it does not equal this, meaning it wasn't empty, we'll convert it to Celsius. So again, we have to actually do the conversion. And so what we'll do is we'll call Celsius to Fahrenheit. Problem. Celsius is a string, so we'll need to actually parse it now as an int. So now that we've split it out, we'll need to parse it as an int. So what we can do is we can return it. We can modify this to return the integer. So it would actually do the parsing, in which case if we found it, we would return the integer, and if we didn't find it, not sure what we would return. So I think we'll do the parsing here for now. So we'll say that and we'll shadow. So again, we're going to use shadowing equal, and we should make this mutable now. Same thing for this. So we're going to shadow Celsius, and we're going to say Celsius is equal to Celsius.parse. And again, parse can return an error, so we're going to need a match case. And if it returns OK, so it's similar to what we're doing here in guessing game. Just pull this up so we can see. Again, this match statement here. So, I already messed it up. So we're going to match, and if it's OK, we're going to get our number, and we're going to return our number. Otherwise, if there's an error, we're going to go ahead and panic. So we're going to do panic, and we'll do the same panic we have here. Okay. And let's do the same thing for Fahrenheit. So similarly, we do this. And I think once we actually convert this to be a tuple and we'll optimize this code, it'll look a lot nicer. So here we're going to say Fahrenheit. And here we're going to call Fahrenheit to Celsius. All right. It's a lot of code. Let's look at some of the things it's complaining about. So here it's saying that we're probably not actually mutating it, so it doesn't need to be mutable. Good to know. Let's get rid of that. And let's run it. Enter a temperature in Celsius. Oh, so we should change that too. Let's change that really quick. It doesn't need to say that anymore. It just says enter. Please input a temperature. Clear that. I'm going to run cargo run. Let's see where we're at. Please input a temperature. I'm going to say 32F. 32F is equal to 0C. Oh, it worked. And we'll probably put this on a loop. Enter a temperature. Let me try 32C. 32C is equal to 89.6F. Is that right? Probably. Let's run it again. Let's do 100C, one that I know, is equal to 212F. Awesome. So pretty cool. So that's working. Let's see what happens when I type in 112, like just nothing. So please enter valid temperature. And so what if I do negative 32C is equal to negative 25.6F? What if I do cargo run? Let's do 0F. Negative 17 Celsius. So pretty cool. And what if I do negative, let's do 0 Fahrenheit. Oh, I did that already. Awesome. So pretty cool. But let's optimize it. So do negative 40C. Okay, so let's do negative 40. Yeah, I think I know where you're going with this, but let's see. Negative 40C is negative 40F. Have we reached absolute zero? What is going on? Damn. Look at that. Maths. Maths, people. Thank you, Clam. That is awesome. But our code is working, regardless of that weirdness. So, let's modify this. Let's have it return a tuple. Let's make it nicer. We're not going to have this messy multiple code thing. So let's change this a bit. So instead of returning, checking is it Celsius, checking is it Fahrenheit, let's just say, hey, give me the temperature from this. And what we'll do is we'll parse out an integer, and we'll parse out the type, Celsius or Fahrenheit. And we'll do a match on it. So we're going to change this to get temperature from string again. It's going to return a tuple. The tuple is going to be of type signed, or it's going to be type F64, comma, string. So it's going to be a tuple. And we're going to go ahead and add back in this condition. Throw an else on there. get rid of this. We still want those functions. Those are still good. Here, we'll need to return. Let's just return 0 empty string. It's got to be an F32, F64, so 0.0. Okay, so here what we're doing is we're going to return the temp string converted to an integer plus the indicator of whether or not it's Fahrenheit or Celsius. So the way we'll do that is we'll actually do our parsing here. So what we're going to say here is we're going to say let temperature equal that, and then we're going to do shadowing. We're going to say temperature equals temperature dot parse, and we're trying to parse this as an F64. So in our parse, we're going to do, so this needs to be a match. So we're going to match. And again, if we get OK with our number, we're going to go ahead and return our number. Otherwise, if we get an error, we're going to go ahead and, if we get an error, let's just go ahead and panic. Invalid temperature is fine. And again, we have to end that in a semicolon because it is in fact an expression. So now we have the temperature. And so what we'll return is the temperature, comma, Fahrenheit. And so we can't implicit return here because it's not the last thing in the list, so we'll have to return like that. And that'll work just fine. Now, one thing worth noting is no matter what, we're going to be parsing the temperature. So we don't need to duplicate this code. So let's not. But let's duplicate it for now, and then we'll clean up this function even further. So this is just an example of refactoring and making things look awesome. So here we'll define temperature as this. We'll parse it here, and we'll change temperature to Celsius. Okay, so this will work, but you can see we have a lot of code duplication. So let's alter that. So what we'll do is we'll create a variable here called what is the word I'm looking for Fahrenheit and Celsius? Is it the standard? In the chat, help me out. Like Fahrenheit and Celsius, what are we talking about here? The unit, that's right, duh, unit. All right, so let unit equal unit, yeah, correct. All right, so let's do let temperature let mute temperature equal, we'll start out with it being 0.0, and then we'll do let mute unit equal Fahrenheit. Okay, so if it's this, we can say we'll just do temperature equals that. Let's move this code out here because we're going to do this for each, so we might as well just move it below. Move that out there. Get rid of this here. So we're going to set temperature equal to this. And here we're going to set temperature equal to this. And the more important thing is we're going to set the unit. We're not going to modify the unit there, but we do need to modify the unit here. Let unit equal Celsius. We actually can leave off the let. We're not shadowing, so we're mutating. So that should do. Absolute unit. All right, so we have the temperature is set to 0 to begin with, Fahrenheit to begin with. If we detect Fahrenheit, we grab the temperature and we convert it. Oh, so it's a string. So we want to specify it's a string to begin with. So it's of type, let's specify here, it's of type string. Let's mutate it so we're not shadowing it. This way we'll get those errors. So if I were to change this back, you'll see that we'll get an actual error. If I change this back to 0.0, and that's because here I'm actually properly trying to mutate. So here, let's change it back to that. Here we're mutating it to that. Here we're mutating it to that. And changing the unit to Celsius. Otherwise, again, if we exhaust the loop, we'll end up out here, and we can change this to be something different. So here here's where we're actually shadowing temperature. So we're taking temperature and converting it into a number, and then here what we'll want to return is temperature and the unit. Okay, so let's recap what we did. So we start out with our temperature is empty. We have our unit as Fahrenheit. If we detect that it's Fahrenheit, we grab that temperature. If we detect that it's Celsius, we grab that temperature and we change the unit to Celsius. We then parse that temperature. So one thing we want to make sure is we don't want to parse unless we've actually ended up in one of these situations. So what we'll do here is we'll add an else continue. And that's so that we continue without going through here. Well, actually what we can do is we can break out here. Well, let's leave it at this for now. So what we're going to do is loop through, find one of these, come down here, we'll return the temperature and the unit. Actually, so this we'll want to do outside the for loop. Why am I doing it in the for loop like a silly person? Hold on. Why did I do that in the for loop? That was silly me. I wasn't paying attention. There we go. Break these out. There we go. Sorry about that. Okay, so outside the for loop, we have declared our temperature string as this, which is nothing. We've declared our unit as Fahrenheit by default. We then loop through. Here we can break out of our loop. Break out of our loop. We then, once we're finished with our loop, we parse temperature. If it's anything that's not a number, we'll have invalid temperature. The one problem with this is if we end up with using the default, so if it tries to parse that, it'll also end up with invalid temperature, which is actually good because it's invalid. Temperature. I feel like I'm spelling this wrong. I'm blanking right now. Yeah, why am I thinking I'm spelling this wrong? Oh, yeah, I knew it looked wrong. Silly me. So we have temperature, we're going to parse it, then we're going to return the temperature and the unit, which is a tuple. Now let's pull out that unit on the other side. So here, instead of this, we're going to say temperature is temperature.trim. And let's pass that to get temperature from string, and we'll pass it this. All right, that'll give us a tuple. So if we look here, it says that it's going to return a tuple. So what we'll have to store is a tuple. So what I'm going to do is I'm going to break it down. I'm going to say temperature, comma, and it's okay that I can say let temperature because again I'm shadowing here. Let temperature and unit. Okay, I can get rid of these. I can get rid of these. I can get rid of this. I can get rid of this. I can get rid of this. All this stuff can go away. All this can go away. So I have my temperature and my unit. And so what I want to do is I can do a conditional. If unit equals Celsius, else if unit equals Fahrenheit, all right, so if unit equals Celsius, I can print out C is equal to F, and I'm going to pass it temperature, and it's equal to get I want Fahrenheit to Celsius. Sorry, I want Celsius to Fahrenheit. Celsius to Fahrenheit, and I want to pass it temperature. And we don't need this type here. Otherwise, let's flip it here. F is equal to RC. Temperature is Fahrenheit to Celsius. And we provide it with an F64, which in our case is temperature again. Here it says we can get rid of our parentheses. Get rid of those, and I'm just going to run my format. Formats that nicely. Let's walk through what we did. Watch out with the typo in Celsius on get temperature from string. Ooh, good call, Gonzalo. Get temperature from string. We have a typo on Celsius with a C. Yes. Great check, great check. All right, so let's run it, and then we'll walk through what we did here. So clear, cargo run. Please enter temperature, 32C, 89F. Please enter temperature. Let's do 32F, 0C. Let's try breaking it. Let's just try 32. Invalid temperature. Let's try 32 lowercase f, or let's try 0 lowercase c, 32f. So awesome. So what do we do? What do we refactor there? Basic stuff. We didn't return we returned a tuple so that we can see not only what the temperature was, but actually determine the unit, right? The absolute unit from what was input. And so the way we did that was we call this get temperature from string. Given a string slice, we return a tuple of a signed 64-bit integer and a string slice. In this case, a reference, right? So we grab the bytes, we set some mutable defaults for temperature and unit. We looped through. If we found the character B or F, we then pulled out a string slice from the beginning of the string to the index up until that F or C. And in this case, we broke right away because our default unit was Fahrenheit. However, in this other case, our default unit didn't work, so we changed the unit to Celsius. And it was okay to change it because, again, it's mutable. Down here, we're using shadowing. We're redeclaring temperature, this time as an F64. So we've leveraged shadowing so we could change the type of temperature. And the way we do that is we try to parse that string. If it works, if we have an appropriate number, that number will be set in temperature. If not, we'll get the panic. We then return that tuple. Here we're doing a conditional on that tuple. However, we could probably just match. We could match on that tuple as well, which would be, I'm sure, like a similar, we can have a compare function. But in this case, an if statement works fine. And what we do is we check if the unit's Celsius, do this. If the unit's Fahrenheit, do this. If the unit was neither, we would have already been catching that within a panic. The unit will always default to Fahrenheit. So we're handling both those situations. We then call the appropriate conversion and print it to the screen. So pretty cool. We've leveraged structs. In this case, we also leveraged our string slicing. We pulled out the bytes, right? So we did it byte by byte, just like pulling each one, looking at it. Remember, we're using the byte literal. That's how we're able to look at it here, using the byte literal. So pretty cool. Right now, it's looking like, the cool things, we're using shadowing, you're using mutability. we wrote this without a lot of complaints from the compiler, which is pretty cool. But again, we are doing mutability, so if we wanted to get rid of this in some form, we could try doing it that way. I think right now, temperature as a string by default, it makes sense because we're modifying it depending on these. But maybe there's a nicer way to not have to declare mutable default that we could try. But this works. We reduced the code quite a bit. Is it readable? I think it's pretty readable. Does it look as nice? I mean, I could probably do this more, just being familiar with JavaScript or Python, I could probably do it more easily there. But again, we're going to lose that safety that we're getting here. So we're getting a lot of the type safety. You notice we are using string slices. We're using basically signed 64-bit integers so that we can deal with negatives. You saw when we didn't use negatives, we got overflow in Fibonacci. Regolo app said, would be cool to write some tests. Yes, it would. We have not gotten to that part in the book yet, so I don't know how to do that. But maybe what I can do is for next session, I can take a little peek ahead and see what it's like to write tests and try that. Although we are trying to stick kind of to the chapters in the book, so I think once we get to that point, we will cross that bridge when we get there, as they say. But yeah, this is a perfect example of writing tests because we could have written our tests and done a little TDD and refactored the code and made sure our test passed. Great question. What book are you reading? So we are reading, Regolo app asked in the chat what book we're reading. We're following along with the main book, the Rust programming language. We've been following along. We're a few chapters in. You can find the other chapters on my GitHub. The repo's there. You can find them on YouTube. And for anybody in the chat who's been joining us late or just popped in, what we're doing is we're going through the book. We just finished chapter 4. We went back and did some exercises from chapter 3. But if you missed out on any of the previous chapters, check out the YouTube channel. Just search my name, Tom McGurl. There's also a link here in the chat where we went over chapters 1 through 4. Regolo app, thank you for the follow. Super appreciated. And yeah, definitely check out those previous sessions on YouTube. I've heard people listening to them on 1.7 speed. Gonzalo, thank you for the follow, my man. Let's go. What VS Code theme is that? Popo RS. So this VS Code theme is Monokai Ocean. So Monokai Ocean. I love it. It looks especially nice with the terminal. I had like a palm tree thing going on before. Now I have like this rusty fall thing. But yeah, Monokai Ocean, highly recommend. So that'll do it for chapter 4 and our chapter 3 exercises. Again, if you missed out, don't worry. You can find the previous sessions on YouTube along with some other awesome videos. We have some videos on here where I go over building a serverless backend. You can see here we got chapter 1. Part 1 is chapter 1 and 2. That's kind of like where we jump in and go through the first few exercises. Part 2 covers chapter 3, where we go into some programming concepts. Regolo app, yeah, interested in learning Rust would be cool to learn with someone else. Yeah, that's exactly why we're out here. I was going to learn it anyway. I figured I'd do it live and let whoever wanted to follow along. We stream on Tuesday, every Tuesday from 9 p.m. to 11 p.m. I might add another day. Right now I've been sticking to that. But yeah, it's totally possible that I add more days there. But definitely check out the stream. Anyone who's interested. Clam, thanks again for hopping by. It has been awesome to have you. Always a pleasure. And yes, I'll see you next Tuesday. Everybody else, thank you for coming online. Again, if you missed out, don't worry. I post these on YouTube. It'll be up tomorrow morning in high quality. It usually posts first in standard def. Wait out for the high quality one. And catch up on the previous chapters on YouTube. And yes, what time zone? Great question. It's going to be 9 p.m. Eastern time, Tuesday nights, 9 p.m. to 11 p.m. Sometimes we go a little over. Sometimes we're getting crazy and we're hacking at it. We go a little bit over. But generally 2 hours, 9 p.m. Eastern, every Tuesday. If I add another day, I'll let you know. Feel free to check out the YouTube. Also, my Twitter handle's there. Follow me on Twitter. That's where you'll get updates on when I go live, when I'm streaming. So definitely hop over there, and if you follow, that'd be awesome. If you like what you see on YouTube, feel free to subscribe, and you'll get those updates on when the videos get posted. And I hope you all enjoyed learning Rust and finishing Chapter 4 and going through those examples. It's really fun to put what we learned to practice. Again, everything on here gets posted on YouTube as well as GitHub. So I take the code that I wrote and I will be pushing it to GitHub. You can see my GitHub URL is here, and the repo is called Learn Rust Live. So I'll open that up here and paste that in the chat as well. So we go to github.com, not git, github.com. I'm on Verizon, classic. Oh, I'm logged out. So I will log in and post it, but the name of the repo is Learn Rust Live, and I will push the code up after this. Again, YouTube video will be posted up by tomorrow morning. It'll be part 4, chapter 4, and exercises from chapter 3. Thanks again for stopping by. I hope everyone has an awesome night, and I will see you all next Tuesday. Take care, Rust Stations.